Aloha, and welcome to the monthly public presentation of the Vegetarian Society of Hawaii. Since 1990, the Vegetarian Society of Hawaii has been following our mission of promoting human health, animal rights, and protection of the environment by means of vegetarian education, as we've grown to become one of the largest all-volunteer, nonprofit vegetarian societies in the nation. It's now time to introduce our special guest. We're delighted to have with us tonight Dr. Janice Stanger. Janice Stanger, PhD, is a nutrition expert, educator, speaker, and author of The Perfect Formula Diet, How to Lose Weight and Get Healthy Now with 6 Kinds of Whole Foods. Her mission is to provide you solid, yet little-known information on whole foods, plant-based diets, so you can choose your diet based on facts, not on myths. Dr. Stanger has a PhD in Human Development and Aging from the University of California, San Francisco. She is certified in plant-based nutrition through the T. Colin Campbell Foundation and has an MBA from the University of California at Berkeley. She has spent 22 years critically analyzing scientific studies on nutrition and health. Her presentation tonight is entitled Food Friends, Food Enemies. Please join me in welcoming Dr. Janice Stanger.
So all foods supply calories, that is energy. But we want to get those calories from foods where the calories are packaged with other good things that are going to help us, that are going to be of net benefit to us. Healthy nutrients. So we want to look at the big picture when we're choosing foods. So food contains thousands of bioactive components. We know this from Dr. T. Colin Campbell's book, really groundbreaking book called Whole. So some of these substances, these thousands of substances in food are beneficial, and some are harmful, and some it really depends on the circumstance. They can be beneficial or harmful depending on the dose and depending on what else you ate with it and other things going on with you. So in any food, no matter what that food is, there's always good stuff and there's always bad stuff. And often we don't even know what these bioactive substances are, because there's a lot more of them that we haven't discovered yet and we don't really know how they work. But nonetheless, for every food, you need to weigh what's the balance between the harmful substances and the beneficial substances. Now, one way you can think about this is with the balance scale, which is illustrated on this slide. And for this particular food, I'm not going to name what it is, but you can see the bad stuff outweighs the good stuff. There might be some good stuff like calories and proteins and maybe some minerals and things. But when you look at it on balance, the bad stuff is weighing it out. So if you think the balance scale is level like this, when the food is just balanced between good and bad stuff, if you put a bunch of bad stuff on it, boom, it weighs it down and it tilts. And so every food is going to tilt one way or the other depending on what's in it and depending on the circumstance. Now here's another way to think of the same thing, which is what I call the pattern value of food, or the p-value of food. And that's just another way of looking at the balance scale. So this is a way of thinking of food where the healthfulness gamut runs from +10, from really, really healthy foods, to -10, to really, really unhealthy foods, and everything in between. And obviously that would correspond to how far the balance scale is tipping. So we need to be able to judge this pattern value of food, and yet we don't even know what all these thousands of bioactive substances are, let alone how they interact. So how are we going to do that? Well, the best way to determine the overall effect of a food on your body is to see what happens when people actually eat it. Imagine that. And this is an evidence-based scientific process. It's a little bit complex, but nonetheless, it can be done. Not all studies agree with each other. We have to really be careful to look for consistency in the weight of the scientific evidence. It's easier to determine, for example, the short-term effect of a food than the long-term effect of a food. That's just one of the very tricky things that go into studying it, and there's a lot more. But we are starting to get enough information to really start making good judgments about how different foods are going to affect our body. So what I call this, when we have actual human beings in the real world eating real food, is running food through the human test tube. And there's other things that people can do to look at the value of food. For example, they can take extracts from the food and use it in cells in a culture, human cells in a culture, and things like that. But nothing is as good as running through the entire human test tube and the complexity of our whole bodies. Okay, so one thing about doing this is we need to look at actual foods or groups of similar foods. We don't want to be looking at macronutrients. That really tells us nothing. So macronutrients are simply the sources of calories in the food. Remember, I just talked about how important calories are, and you need them to stay alive, and you can only live a few minutes without a constant source of energy to keep your cells going. So the macronutrients supply that, and the three macronutrients, you probably already know this, are proteins, carbohydrates, and fats, which your body burns for calories. Now, some of these have other roles in your body, but that's their most essential function, is just to provide energy to keep you going. Now, there's a lot of studies out there. There's one that recently came out that got a lot of publicity just in the last couple weeks, but there's any number of these studies out there that tend to look at, are fats better, are carbohydrates better, or should we be low carb or high carb or low fat or high fat, and all this kind of stuff. Well, this is really totally meaningless, because when you look at the studies on carbohydrates, they group all carbohydrates. So they group everything from soda and lollipops and donuts to lentils and brown rice and quinoa and really good food. So it makes absolutely no sense, and yet they persist in doing it, and these studies get published in the best medical journals, and they get headlines in the best newspapers and all over the internet, and it makes people think oftentimes, and these studies are poorly done, which they almost always are, because they're asking a research question that makes no sense, that people are very mystified and they don't know what's healthy and they don't know what to eat. Well, here's what these kind of studies are like. What if I wanted to do a study and I wanted to see how liquids that you drank an hour before you got in your car affected your driving? So I grouped all liquids together, right? I had my whiskeys and my wines and my beers, which, by the way, aren't even alike. And I grouped them in with water and coffee and tea and soda and energy drinks. And I just grouped them all together because they were all liquids. And then I tried to see, when people drank 8 ounces of liquid before they got in their car, how likely were they to get in an accident? What do you think a study like that would find? Well, personally, I have no idea what the study would find, because it's a stupid study, and depending how it was done and who they picked as subjects and how they collected the data, it might show liquids were good for driving if people were drinking mostly coffee and it kept them awake at 3 in the morning and so they didn't fall asleep at the wheel, or it might show that liquids were bad for driving if most people were at a party and they just had a bunch of alcoholic beverages. But the fact is, it's a really ill-conceived study, and you're not going to find anything meaningful. And it's very analogous to studies that group all carbs together, because all carbs are no more alike than all liquids are alike. So as I'm going through this, please keep that in mind, okay? So let's start getting onto our particular food friends, food enemies. And as I go through this, I'm going to really rely on published research. So the first food friend is actually fruit, which is widely reputed these days to be unhealthy because it contains sugar. So what people are doing is they're mixing up these beautiful whole fruits with fruit candies, which are really nothing but mixtures of sweeteners and chemicals and all kinds of bad stuff. Well, guess what? They're not the same. Just because they both have sugar in them does not mean it's the same. That's the kind of focus on one little thing out of thousands and thousands and thousands in food, or you have a whole balance scale with thousands of things in one and thousands in the other. People are going, oh no, all that's important is the sugar. It doesn't make sense, and that's going to be true as we go through all these different food friends and the food enemies as well. So I've met a lot of people who are afraid to eat fruit anymore because it contains sugar, and that's really depriving them of some very good things. So let's see what happens when we actually run fruit through the human test tube and looking at, again, these published peer-reviewed studies. So far from fruit contributing to weight problems, people who eat more fruit, even the much feared dry fruit, actually tend to be of a more normal weight. In other words, they're less likely to be overweight than people who avoid fruit. Eating whole fruits is associated with a lower risk of diabetes and of developing diabetic retinopathy if you already have diabetes. And some other research indicates that fruit decreases the risk of, for example, cardiovascular disease, high cholesterol, cancer, and asthma. So again, all these kind of accusations you hear against fruit, totally false. Food friend 2 is soy. So these two, again, are not the same. So phytoestrogens, the reason people aren't supposed to eat soy, according to people who really pay no attention to nutritional research, is that phytoestrogens, and these are plant substances that are very loosely akin to estrogens that are in animals. There's a lot of kinds of phytoestrogens. Sometimes they have estrogenic effects, sometimes they have antiestrogenic effects, that is, they actually counter the action of estrogen. But the point about all of them is their action in the human body is way weaker than actual animal estrogens would be because they're from plants, right? And plants have a totally different biology than humans do. Now, cows produce animal estrogen. So dairy foods actually are full of animal estrogen, and when you consume them, whether you're drinking milk or whatever form of dairy food you're eating, you are getting estrogen, and this has been documented and known a long time. There's also a good amount of estrogen in eggs. So, if you're concerned about the estrogenic effects of food, you should be eating soy and worrying about the animal estrogen in animal foods. Okay, let's look at the effect on the human test tube. There's one study I want to talk about real briefly, 20 years of soy research summarized. This came out in 2010 in the Journal of Nutrition. But there's a lot more research showing the beneficial effects of soy. Generally, you find soy is protective against breast and prostate cancer risk. The information on soy and breast cancer recurrence is from a 2014 report from the World Cancer Research Fund, and based on their findings, they actually recommend that breast cancer survivors eat soy foods because it helps reduce the risk of breast cancer recurrence. So that's what happens when you run soy through the human test tube. Now, be sure to eat soy that's either minimally processed, for example, edamame, tofu, tempeh, miso, soy milk, things like that. You don't want to eat soy oil, and you don't want to eat the isolated soy protein, and also you don't want to eat GMO. But with those caveats, soy is a perfectly wonderful food. So let's go into food friend 3, which is nuts and seeds. And this is another controversy. Let's see why. Nuts do have a lot of their calories from fat. Remember, we talked about macronutrients, and one of the macronutrients that's highest in nuts is actually fat. But that does not make whole nuts that are either raw or dry roasted the same as extracted oils, which are oils that are removed from the whole food. They're just not the same thing. So many people are avoiding foods high in fat, and so they'll avoid nuts. Well, let's see what happens when we run nuts through the human test tube. So the main concern with fat is that it's a very, very dense source of calories. There's over twice as many calories in a spoonful of fats than there is in a spoonful of either proteins or carbohydrates. And yet consuming nuts is not found to be associated with weight gain or obesity. And nuts are associated with a lower risk of chronic illness, including cardiovascular disease and diabetes. There's not as much data on seeds as a category. There are in some individual seeds, such as flax seeds, that finds them very healthful. Now, in terms of the nuts being limited to an ounce or two a day, that's not something that's really been solidly researched, how much you should eat, but it's kind of a consensus that's out there among people that research plant-based nutrition, and I think it's a reasonable guideline. You don't want to eat huge amounts of nuts because that would kind of take so many calories out of your day that you wouldn't have room in your body to eat too much else, or you'd be going over your calorie limit for the day. But just having what's basically a handful or two of nuts a day, or a tablespoon or two of nut butters, for most people is perfectly reasonable choice. Okay, let's get into food friend 4, which is whole grains. Now, whole grains are the most misunderstood and the most maligned, unfairly maligned whole food there is. So let's start with what whole grains actually are, which is something that most people that malign them actually don't even know or pretend that they don't know. So whole grains are the seeds of certain grasses. And it shows you the parts of a whole grain. Now, whole grains are seeds, and here's a part of a seed that's a whole grain. It's also the part of pretty much any other seed. So the germ, what's called the germ, is actually the baby plant. It's a teeny tiny plant embryo that's going to grow to be a full-fledged plant given the right conditions. You've got the endosperm, which stores all the calories and other nutrients that the baby plant needs until it gets big enough and grows leaves and can start making its own food. And you have the bran, which is a protective outer layer that protects everything inside until it should be ready to germinate. So we had just considered the effect of seeds in the prior food friend that store most of their calories as fats. And whole grains are seeds that store most of their calories as complex carbohydrates. There's no particular reason if you listen to a lot of people that go, oh, fats are good and you should eat a lot of nuts, but whole grains are bad. Doesn't make sense, they're all seeds. And some examples of whole grains include things like brown rice, whole wheat, oats, quinoa, millet, and rye, barley. There's a lot more. Now, you might hear some people making a difference between whole grains, which are the seeds of certain grasses, and pseudograins, which are the seeds of certain other kind of plants that aren't grasses. Well, if you're a PhD biologist, that really makes a difference. You're writing your PhD dissertation of botany or something. You want to make sure you understand your plant classifications. If you're just somebody who's hungry, who's trying to figure out what to cook for dinner, you really don't have to worry about that at all because their nutritional profile is very similar. So the problem that's usually alleged with whole grains is carbohydrates. So we just got done talking about carbohydrates and how silly that is and how people are grouping, as I show here, white bread and whole grain bread. They're not the same thing, and yet people group them together because they're just looking at carbs. And the mistake of turning carbs into villains is really silly when you understand that carbohydrates are your body's preferred energy source to keep you running uphill all day long, and actually you're still running uphill all night long because at night you're burning energy to do things like breathe and keep your heart beating and dream and all those things. You need calories all night long as well as you need them all day long, and carbs are what your body prefers to burn when it has a choice to do so. Okay, let's look at the human test tube again. Whole grains are associated with a lower risk of diabetes and lower blood pressure. Eating whole grains has been found many times to lower the risk of certain cancers. And eating more whole grains actually reduces the risk of mortality over whatever time period a study is usually looking at. So we can see the effect of whole grains on the human test tube is good. It's not like I'm withholding purposely studies that show whole grains being unhealthy. I guarantee you I'm not withholding any studies that I know about. And here I'm not talking about people that have a specific food sensitivity, such as somebody with celiac who can't eat gluten. I mean, clearly there are people with specific sensitivities to almost any food that you can name. What we're looking about is the general population, and I'm not aware of any studies that show whole grains are unhealthy for most people. And if you come across such a study, I'd appreciate if you send it to me. It has to be in a peer-reviewed journal, that has published data and everything like that. Please don't bother to send me a blog because I need something that's been scientifically referenced. Okay, so let's look at our last food friend for tonight, which is legumes. And legumes generally includes peas, beans, lentils, things like that. And again, these are more seeds. Legumes are basically seeds, just like a lot of things we look at. A lot of the foods we eat are actually seeds. They're just different kinds. And so they fall in different classes, but they're all food friends. So let's look at what people are confusing. And one thing that gets held against legumes, and oftentimes a lot of things are held against legumes, but one of the primary ones that's held against them these days are actually substances called lectins. So in the upper left, you have a very flavorful, whole food, plant-based chili. And in the lower right, you have ricin, which is castor bean. And ricin is a lectin in the castor bean that is extremely deadly. It's a very deadly poison. So please don't ever eat castor beans or handle ricin. So what the paleo myth does, it tries to expand the harmfulness of ricin to all lectins, but this is a major error in thinking. It's just a logical fallacy. So let me say a few words about lectins. They're a diverse protein family that binds to carbohydrates. They're one part of a plant's defenses against pathogens, and they're present in plants of all kinds. There's so many lectins out there, we don't even know how many there are. There could be thousands, hundreds of thousands, there could even be millions. We don't know, because they're in so many different foods. You can hardly eat without eating lectins. Lectins are generally destroyed by cooking in any case because they're proteins, and proteins get kind of unwound and their structure changes when you cook them. Therefore, lectins being proteins, their kind of biochemical action is going to be destroyed when you cook them. So let's look at the logical fallacy of some people who are kind of concerned about this whole lectin thing. So I want to show you how nonsensical this logic is. And we're going to start out with something we know about, which is snakes, and therefore you'll be able to see the logic, and you'll be able to see when we get to the lectins how silly the logic is. So here we go. Cobras are poisonous. Everybody agrees, check. Cobras are snakes. Everybody agrees, check. All snakes are poisonous. Anybody think that's true? It's just bad logic, that's all there is to it. And yet that's the same kind of logic this whole lectin myth rests on. Let me get to that one. It's exactly the analogous structure. Ricin is poisonous. Yes, it is. Ricin is a lectin. Yes, it is. All lectins are poisonous. Now, you might fall for this one because you don't know what lectins are. You have no idea what they are, and so you can't really think about it clearly. But when I went through the same logic for snakes, you knew I was wrong. You knew there was something wrong because you know all snakes aren't poisonous. And it's the same logic here. All lectins aren't poisonous any more than all snakes are poisonous. So let's see what happens when we run legumes through the human body. So there was an international study done that was published in 2004, and it looked at elderly people in 4 countries, and it showed the only type of food that was consistently associated with longevity were legumes. Legumes lower the risk of diabetes, cardiovascular disease, obesity, and more. They also lower the risk of cognitive decline in the elderly. And so based on published evidence, there's really no mistaking the fact that legumes are food friends. So now we've looked at a bunch of food friends that you've probably heard a lot of myths about. So now we're going to move on to food enemies. We don't have time to cover them all. So I've only picked out one type of food enemy to talk about today, and here we go. Combined animal foods. Now, I will mention briefly toward the end some other food enemies, but this is the one I want to concentrate on because it's the one where there's actually the most myths out there. Now, by animal foods, I'm including animal muscles, organs, and secretions, and reproductive products, and all that kind of thing. And by the way, fish are animals too. A lot of people don't seem to realize that. So by grouping all animal foods together, we really accomplish something. And what we accomplish by doing this is that there's a lot of myths out there that say, okay, certain kind of animal foods are unhealthy, but certain kinds are healthy, and people are told this. And so what happens is it causes a change in people's behavior. So people are told, for example, skinless chicken breast is healthy, and fish is healthy, and egg whites are healthy. So guess what happens? People who are health conscious will then eat those animal foods. But those health conscious people are going to have a whole lot of other good habits too. For example, they might be more likely to not smoke. They might be more likely to get enough sleep. They might be more likely to exercise. They might be more likely to go to yoga classes and practice stress management and so on. And when researchers go to try to correct for all those things, statistically, guess what? They can't really fully do it. They can correct to a small extent, but to the most extent they can't. So what we get is a lot of health-conscious people eating animal foods they're told is healthy, makes it very hard to discern what the action of these foods actually are in the human test tube, because different kind of people are eating them. So by combining all animal foods together, then we kind of get around this methodological problem. So it's worth looking at. Okay, so if we want to combine all animal foods together, how would we go about studying that? Well, one way of doing it is to look at percent of calories that come from animal foods, and that would be ideal. That would be my preference about how to study it, to say if somebody gets 1% of their calories from animal foods, or 5%, or 10%, or 20%, or 50%, or whatever it is, that's how we would judge. But very often we don't have that information. What tends to get studied more often is actually animal protein consumption, and there's a fair amount of studies on animal protein consumption. Now, this isn't a perfect indicator for how many animal foods people are eating, because if people are eating fattier animal foods, they're going to be getting more calories from fat, so it'll kind of underestimate the amount of animal foods people are eating. And if they're drinking a lot of milk, it also underestimates it, because milk has lactose in it, which is a kind of sugar, or you could think of it as kind of an animal carbohydrate. So all that gets left out when we just look at animal protein, but nonetheless is probably the best measure we have right now to look at animal foods combined. So let's see what we're starting with. Okay, so we're going to be running these animal foods through the human test tube and see what we find. So we're never going to get perfect consistency in studying a subject as complex as nutrition. What we want to try to look at is the weight of evidence. We want to try to look at the weight of evidence and see which way the wind is blowing. It's hard to tease out the effect of self-selection, but we're going to try to do that. So the China study was the pioneer in looking at this. The China study's been called the Grand Prix of epidemiology. It was performed by Dr. T. Colin Campbell and his colleagues back in the 1980s in rural China. And back there, people were getting very few calories from animal foods. They were only getting about 1% of their calories from animal protein. Now, there were differences in diet across China, so that the researchers could compare people who ate more animal foods with those eating less animal foods, even though none of them ate nearly as many animal foods as people in the developed countries do. So here's one of the conclusions that Dr. Campbell came to in writing about the China study. I'm going to read a quote here. He says, "We expected that when animal protein consumption and blood cholesterol levels were as low as they were in rural China, there would be no further association with Western diseases. But we were wrong. Even these small amounts of animal-based food in rural China raise the risk for Western diseases," end of quote. So in this study, Western diseases were the kind of things that we study from, we suffer from here in the West. It's things like heart disease, diabetes, many forms of cancer, the things that are leading killers in the United States and many other developed countries. So let's look at some other published studies. The China study blazed away, but there's been a lot that's happened since. So, for example, we'll start out focusing on cancer. So a study published in the journal European Urology in 2004 looked at prostate cancer across 32 countries. The researchers found the strongest risk factor for death from prostate cancer was eating animal foods. A study published in the American Journal of Epidemiology in 2004 looked at women with non-Hodgkin's lymphoma. Those who ate the most animal protein had a 70% greater chance of developing this disease. A study published in the European Journal of Cancer in 2010 found those who ate the most animal protein had an 85% increased risk of developing pancreatic cancer. A study published in the journal Nutrients in 2014 looked at 21 types of cancer in 157 countries. The researchers concluded that eating a higher percent of calories from animal protein increased the risk of 12 kinds of cancer. Okay, so that's just a sampling of the studies. Let's move on to some other kinds of illness away from cancer. A large European study published in Diabetes Care in 2014 concluded the frequency of developing type 2 diabetes was higher in people with a higher intake of animal protein. A study published in the American Journal of Gastroenterology in 2010 found high animal protein intake associated with significantly increased risk of inflammatory bowel disease. Women who ate more animal protein relative to plant protein were 3.7 times as likely to get a hip fracture, according to a 2001 study in the American Journal of Clinical Nutrition. A study in JAMA Internal Medicine published in 2016 found that in 2 U.S. groups totaling over 131,000 participants, animal protein intake was linked to a higher risk of dying from cardiovascular disease. So as I said, there's additional studies. There's also studies that, for example, look at high protein diets versus people who are on a high carb diet or just a regular old standard American diet. There's studies, for example, with Seventh-day Adventist groups where there's variations in what people within the Seventh-day Adventist group eat. And again, all these studies pretty much favor in a very high percent of the time that you're better off eating plant foods than animal foods. So what these studies indicate, and this is really important when you combine it all together, that you probably can't lower your risk of disease very much by just switching from one kind of animal food to another kind. Okay, so let's look at mechanisms of harm. So what is it about animal foods that leads them to be so dangerous, to really give us hazardous results in the human test tube? Well, I'm only going to be able to look at a few of the mechanisms tonight, but I want to pick out some of the more unfamiliar ones you might not know about as things that are true of many different kind of animal foods. And as we go through it, remember these are all things that have been studied and documented in peer-reviewed journals. Now this information, again, is not meant to be all-inclusive, it's just meant to get you thinking. So there's 3 main mechanisms of harm from eating animal foods. The first is just eating the animal foods. The second is breathing smoke and fumes from cooking animal foods, and the third is getting infections either directly or indirectly from animal foods. And we'll look at each of these briefly. So when you're looking at eating animal foods, there's several mechanisms of harm. I said we'll start out with hormones. I already talked about this a little bit back when we were talking about soy. So what hormones are is they're chemical messengers that help coordinate the actions around your body. Now, all animal foods contain hormones. Why is that? Because every animal needs hormones to function. So even if you're eating an animal that was raised without added hormones, it's still going to have hormones circulating in its bloodstream because when it was alive at the moment that it was killed, there were hormones circulating in its body that were needed to keep it going. Basically, we all have hormones circulating all the time. And the thing about hormones is they're extremely powerful even in tiny amounts. So when you're randomly eating extra amounts of hormones in animal foods, here, there, and everywhere, and your body doesn't quite know what to expect when, what are you going to eat and how many hormones are going to be in it, because one animal might have a different, hormone profile than another animal, so your body never knows what to expect. Meanwhile, it's trying to keep your hormones within very strict levels because that's what you need to function optimally. So you can imagine this can kind of play havoc with your hormone levels. Estrogen and testosterone are in animal food. That's something that can directly raise your risk of reproductive cancers. Okay, so there was a 2017 article in the Asian Australis journal Animal Science, and it states, I'm going to quote here, "Stress activates the animal's hypothalamic pituitary adrenal activity, triggering release of various stress hormones such as catecholamines and cortisol," end of quote. So people may spend a lot of time and energy on stress management only to then consume all those stress hormones in meat. And also want you to consider IGF-1, which is a hormone. It's a little-known hormone made in your liver. It stands for insulin-like growth factor 1. And what IGF-1 is a key controller of cell division and death and lifespan. It also tends to facilitate cancer. There's been a lot of studies linking higher levels of IGF-1 with cancer. So when you're eating animal foods, your body's making more IGF-1, and also dairy foods contain IGF-1, so you're getting higher levels of IGF-1. And again, the tendency of IGF-1 is going to be to promote cancer. So let's move on to another hazard, the persistent organic pollutants. So these are deadly chemicals. There's over 85,000 chemicals that are used in the U.S. They're not all persistent organic pollutants, but many of them are. Many are also left over from decades ago. They haven't been used in a long time, but as you can guess from the name, they persist in the environment. They're commonly found in a lot of different substances, such as pesticides and herbicides and building materials and flame retardants, and a lot of other materials. So harmful effects of persistent organic pollutants include things like cancer, nervous system damage, Parkinson's disease, and reproductive disorders, and there's a long list more. Now, these chemicals are largely stable in the environment. They're carried around the planet by wind currents, by water currents, and they're in every part of the planet. There's literally not a single part of the planet you can go to, even in Antarctica, that has not been contaminated to some degree by persistent organic pollutants. And the reason it's important to be aware of them when you're eating is because they tend to bioaccumulate in fat. What that means is they dissolve in fat. They're not really water soluble. So as you move up the food chain, and we know that animals contain a lot more fat generally than most plants do, these persistent organic pollutants are dissolved in the animal's fat. And so the next animal that eats the animal that has these persistent organic pollutants in it tends to bioaccumulate even more of it. So, for example, animal foods are the source of 95% of dioxins and dioxin-like compounds in humans, and that's the upshot of it. That information, by the way, is from an article in the journal Environmental Health Perspectives. And those authors included meat, dairy, and fish in animal foods when they gave that statistic. So let's move on to another hazard that's common in animal foods is metals. So some metals are needed by your body in fairly small amounts, and that includes like iron. Your body wants to get just the right amount of iron, not too much and not too little. There's other metals, such as mercury, that really don't belong in your body at all. And if it's there, that's bad news because the optimal level is 0. So let's start out with iron. So heme iron is a kind of iron that is in animal foods. And as I said, your body very carefully regulates the amount of iron that it has, because too much, it becomes a pro-oxidant, it causes dangerous free radicals. And so your body wants enough to be able to have red blood cells and be able to do its job, but it doesn't want to store like lots and lots and lots of iron. So it has very elaborate mechanisms to make sure that it absorbs just the right amount of iron from the food you eat, because a lot of plant foods are very rich in iron. Your body doesn't need all that iron, so it deliberately absorbs some and lets the rest go, because it doesn't want every molecule of iron in your food. Well, the heme iron in animal foods tends to get overabsorbed because the mechanisms that regulate the absorption don't work as well with heme iron, and it leads to the accumulation of iron. Symptoms of iron toxicity include digestive system disease, infections, fatigue, joint pain, and organ damage. And excess iron has also been linked to heart disease and cancer, as well as I said, causing the formation of dangerous free radicals. Well, at least iron is something you should have in your body, right? That's a good thing. So let's look back at mercury, because you shouldn't have any mercury in your body. But there's mercury in all fish and in all shellfish. It's unavoidable these days. Unfortunately, that wasn't always the case, but now our planet's been polluted, and there it is. Okay, and since fish meal is also fed to farmed animals to fatten them up, it's quite possible there's also some mercury in other kinds of meat. That hasn't been much studied. I've been looking for some references on that, so that's just something to keep in mind at this point, more as a theory than a fact, but just kind of keep it in the back of your mind as a possibility. So mercury accumulates in fish's bodies, and then when you eat it, it accumulates in your body, because since it's not supposed to be in your body at all, your body has no very good way of coping with it or getting rid of it. So when you eat low mercury fish, what happens? The mercury's still accumulating, you're just kind of delaying the day of reckoning because it's accumulating at a slower pace. But it doesn't mean that you're safe or out of the woods or anything. It just means you're accumulating mercury more slowly, but that doesn't mean you're not going to get to a dangerous level, especially if you feel like, oh, I'm eating low mercury fish, this is good for me, I can eat as much of it as I want, and then you end up eating more mercury because you're eating more fish. Okay. So I want to go on to one other mechanism of harm from eating animal foods, and that's advanced glycation end products, which are also called AGEs. And these form when proteins and fats are cooked at high temperatures, especially with dry heat and in the presence of sugar. And you might say, well, that rules out animal food because animal food then has sugar in it. But in fact, they do, because some sugars are part of the structure of the animal cell. And also, for example, muscle stores glycogen, which is a kind of sugar in a sugar chain. Just like, our muscles store glycogen. They just use it for energy. So there is sugar present. And so you have all the kind of ingredients to make AGEs when you cook animal foods. So according to a 2010 article from the Academy of Nutrition and Dietetics, the food with the highest amount of AGEs per serving is actually fried bacon, with a level of 11,905. Boiled hot dogs have a level of 10,143 per serving. Fried chicken, 8,750 units per serving. So let's contrast that with some plant foods. Raw pumpkin seeds have 556 units. A toasted bagel, 50 units. An apple, 13 units. I think you're seeing a little bit of a difference here. Now, some broiled and roasted plant foods can have higher levels of AGEs, but typically plant foods aren't charred and cooked as long or as at a high temperature as animal foods are, so it's less likely to be a problem. Whereas animal foods are often cooked, for example, through smoking, barbecuing, grilling, broiling. All those are very high temperature methods of cooking that cause these AGEs to form. Let's move on to harm from breathing. In this case, I'm just going to look at one component of some of the chemicals in fumes that you get when you cook animal foods, and those are called polycyclic aromatic hydrocarbons, or also known as PAHs. Now, a lot of the components of smoke from cooking animal foods are the same as the components of smoke from burning tobacco. Now, obviously, there's no nicotine when you burn animal foods, but a lot of the other components are very similar because you're basically you're doing incomplete burning of organic matter. But we're just going to concentrate on the PAHs now. So these, again, they're a product of incomplete burning of materials that contain carbon, which is to say materials that used to be alive, whether they're plant or animals. So these chemicals get in your body from breathing smoke and also from eating any that have been deposited on the surface of foods. For example, if you're cooking some kind of animal food on a grill, you're generating PAHs in the smoke, and also some are getting deposited on the surface of the animal food, so you'll be eating them as well. And again, just like AGEs, these are generated when animal foods are cooked at high temperature, for example, through broiling, grilling, those kind of things. So health issues from breathing or eating PAHs include cancer, lowered IQ for developing fetuses, damage to your lungs, liver, skin, red blood cells, and more. And again, as I said, burning plant foods isn't good either in terms of AGEs or PAHs, but again, it's much less common that you're going to be cooking plant foods at such a high temperature, but the bottom line is if you burn your plant food and it becomes a, charred cinder and it's just a really burnt piece of toast, or you left it on the grill too long and now your onions have turned completely black or something, just really your best off throwing them out and not eating them, okay? Because we don't want to compound things here. All right, so let's look at harm from infection or food poisoning. Now, if you've ever had food poisoning, you know it's a really miserable experience, just an absolutely miserable experience, one you'll never want to repeat. But according to the CDC, about 48 million Americans a year suffer from food poisoning, so it's very common. Usually it doesn't cause serious long-term effects. Usually it's just 1 to a few days of feeling really miserable and maybe having to miss work or school and, just kind of feeling like you wish you were out of your misery, but you get over it. But there could be long-term damages, for example, to your neurological system, and sometimes food poisoning even results in death. Now, one thing I want to stress is humans don't get plant diseases. So if you have food poisoning, you're not getting a plant disease. You're getting it from some kind of microbe or other agent that is from an animal food, because this can be either direct or indirect. So you can get this microbe, for example, from eating the animal food directly, or you can get it from contaminated plant foods, because plant foods do get contaminated. Often this happens when they're irrigated with water that comes from somewhere that had animal feces. Unfortunately, then it gets on the plants and you can get it from plants. So always make sure you wash your plants. But if you do get food poisoning from plants, just keep in the back of your mind that the microbe came originally from an animal. So let's look at a few common types of food poisoning. I just had them lifted up there. We have Campylobacter, commonly from dairy and poultry, Salmonella, which is commonly from poultry and eggs, and Vibrio, which is commonly from shellfish and other seafood. Now, there's one particular kind of foodborne infection that people find especially gross. It's not necessarily even as dangerous as the other kinds, but people just find it really like, ugh, I don't want to think about this, and that's parasites. Now, parasites can be very small. They can be too small for you to really even see with the naked eye, but they can be bigger. And honestly, to not kind of sugarcoat the truth, they're actually worms. So most people don't like the idea of these worms living inside their body, and that's why they get kind of grossed out by parasites. Now, meat may be infected with worms and worm eggs. And this is actually even more likely when an animal is pasture raised, because then the animals out there in the pasture are being in contact with the environment and all these parasites than it would be, for example, what's confined in a barn its whole life. Now, very often cooking will kill parasites, but you have to make sure the food you're cooking is very thoroughly cooked, because incomplete cooking can not necessarily kill the parasites. So you want to be really careful about that. Now, for sushi, by definition, you eat sushi raw. So what about the parasites in raw fish? Different countries have different requirements. In the U.S., restaurants that are serving sushi are supposed to freeze them. And the FDA has specific guidelines for how long and to what temperature the fish should be frozen before it's served to humans. And oftentimes the temperatures that they're supposed to be frozen at is not the temperatures you're going to get in your home freezer. So, this might be hard to do at home. And again, if you're at a restaurant, you don't know if they really froze it properly. You can really just hope they did if you're eating the sushi, because other than that, you could definitely get infected from it. Okay, so these are all the dangers we have time to cover tonight. Let's go on to a way of eating that's going to balance the scale in your favor. Remember our balance scale? You want to balance it in your favor? Here's one way to do it. So from all the evidence we looked at tonight, all the journal articles that I mentioned to you, you can see what the upshot is when you're looking for consistency in findings, and that's that a whole food, plant-based diet, a wide variety of whole plant foods, is going to help you be eating a healthful diet that's based on food friends, a diet that has a high p-value, a high pattern value, however you want to think of it. And if you already have a whole food plant-based diet you like, that you're doing well on, that you've been eating for a while, then just keep doing it. Like I never say mess with success, don't mess with success. If you're still looking for that kind of information and you want to try a whole food plant-based diet and you're not really sure which way to go, then I'm going to make a suggestion to you, and this is what I call the perfect formula diet. So the 4 pillars are vegetables, fruit, potatoes and or legumes in any combination, and whole grains. And you're going to eat a quarter of each, and the quarter is really by volume. So for example, if say you had a cup, if you had a cup of one, then you'd eat a cup of the other and the other and the other till you'd eat one of each. But you really don't have to be that kind of rigorous about it. The point is not that you're going to get out a measuring cup and measure your food, because I really don't want you to do that. The point is that you're going to eat abundantly of all these different kind of foods. So you're not going to avoid one category of foods. You're not going to say, oh, I don't eat carbs, I don't eat grains, and I don't eat legumes. You're going to have a very hard time succeeding if you do that. If you try living only on fruits and vegetables, you're not going to be getting enough calories, and we start off talking about how essential calories are. You're going to be famished, and you're going to end up eating some foods that really aren't nearly as good for you. So that's why you have to eat all these different kind of foods. Okay, so there's some other things you can eat. First off, you want to have your food be delicious. That's very important. You want to have it be fragrant. And so you want to have spices in your food, herbs and spices. Those really help you appreciate your food. Okay, and they're also full of phytochemicals. You don't want to take the phytochemicals in a pill. For example, you don't want to eat a pill full of an herb, or for example, garlic or turmeric or something like that. You want to eat the whole food. Okay, and just sprinkle it on your food. You don't want to be eating it by the spoonful. Again, that can just be toxic excess. If something, I always like to say, people in this country always think if a little is good, then more is better, but that's not true. If a little is good, then more is probably toxic excess. So that's certainly true with herbs and spices. Sprinkle them freely on your food, but don't eat them by the spoonful or the capsuleful or anything like that, because they can very packed with bioactive substances. Also, we talked about nuts being a food friend. So you don't want to have a quarter of your food volume be nuts. But you do want to eat small amounts of nuts. That's perfectly fine unless you're allergic to them or you don't want to eat them for some other reason, to eat an ounce or two a day or maybe an ounce or two a week or whenever you're kind of moved to eat them, but just feel free to enjoy that. Now notice I didn't mention how much to eat. I'm telling you what to eat, but I'm not telling you how much to eat. Well, guess who's going to tell you how much to eat? You're going to tell yourself how much to eat, and it's going to be based on your appetite. So on this kind of diet, as on just about all whole food plant-based diets, your appetite is your guide. You eat when you're hungry, usually when you're moderately hungry is good, and then you stop eating when you're full. And then you don't eat again till you're hungry again. You might be hungry again in 2 hours. That's perfectly fine. Then you're going to eat again in 2 hours. You might not be hungry again for 4 hours. That's when you'll eat again. So you need to listen to your body, because your body has very elaborate mechanisms to control the amount of calories you eat, to control the amount of nutrients you eat, to control the amount of nutrients you absorb. And as long as you stay out of your own way and you're eating a diet based on whole plant foods, your body can do its job. But when you're eating a lot of food enemies, and by the way, I didn't get a chance to mention this, but you see what's not in the diet, which are extracted oils, highly processed plant foods. Extracted oils are the worst highly processed plant foods. You also don't want to be eating, for example, powdered sugars and foods made with a lot of unpronounceable chemicals and things like that. So those are also not good. We didn't have time to cover those tonight, but keep that in mind that we're talking here about whole foods. We're not talking about processed plant foods, because those will also mess up your appetite and, the functioning of your body as well. So are you going to mess up sometimes? Of course, nobody's perfect. I'd be the first to put myself in the non-perfect category. So what I tell people is if you're getting 95% of your calories from whole plant foods, from a wide variety of whole plant foods, you're doing pretty good. That leaves you with what I think of as a budget of 5% of your calories for things that aren't whole plant foods. And maybe that's where you want to have some dark chocolate, or you want to have some kind of sugar-sweetened dessert because it's your birthday, your best friend's birthday, or something like that. That becomes part of your 5% of calories budget. And for most people, that will kind of run out to be approximately 700 calories a week. So I see that as a fairly generous budget. I never go anywhere near that height anymore. I mean, I used to back when I first started eating this diet, but I almost never eat anywhere near 700 calories a week in kind of junk plant foods. But, if you want to do that, that's fine. You're still going to be doing way better than most people. And if you hold yourself to a standard of perfection, and you fall off the wagon, you're going to start feeling really bad about yourself, and there's no reason to do that. We don't have to be perfect. Remember, it's a balance. So if your balance is tipped this way 95% of the time and tipped a little bit that way 5% of the time, you're still kind of coming out all to the good, I think you can see. There's a few simple additions to the foods I just talked about. I like to eat ground flaxseed. It's been found to be very beneficial. It's one of the few domesticated foods that has high levels of omega-3 fatty acids in it. Chia seeds being another one, but flax seeds are generally a lot less expensive. So you can eat a tablespoon or two a day of ground flax seeds sprinkled on your cereal, put in your oatmeal, your smoothies, your salads, however you want to eat, it's fine. And again, if you skip a day or two, that's fine. You don't have to be going to bed. And I go, oh my, I never ate my flaxseed, and spring out of bed and run down and eat some. It's not that important. It's just something you want to try to get some of, a lot of days when you think of it. Vitamin B12 is actually a vitamin that's made by bacteria and not by plants. So even if you're eating whole plant foods, you're not necessarily going to get a lot of B12 unless they're contaminated with bacteria. And even the same with animal foods. And a lot of people say, well, you get plenty of B12 if you eat animal foods. It's not necessarily so. Some animal foods will have B12 and some might be lacking it. You just really can't necessarily know the dose in advance. So the best thing to do with B12, no matter what diet you're on, is just take a supplement. And finally, vitamin D is actually not even a vitamin, it's a hormone. It's a substance made by your skin when sun hits it. So what you want to do is try to get some sun. Your body can make its own vitamin D. You don't want to get sunburn. Definitely don't want to get sunburn. And some people might have to avoid the sun for medical reasons. But if you can get a little bit of sun and let your body make its own vitamin D, there's very beneficial aspects of the sun, even in addition to vitamin D. That's generally, for most people, again, unless there's a medical reason not to, a good thing to do. So again, to sum up everything we talked about, and I really invite you to go out and do your own research. There's no reason you should necessarily believe me. You should go out and look in medical journals. You can find a lot of information on PubMed.com. It's basically the U.S. government's index to publish peer-reviewed medical journals, not just from the U.S., but from many other countries around the world, and has nutrition journals as well in it. So you can use that to look up the subject that's of interest to you. And I really do invite you to do your own research. Try not to get confused, because oftentimes you might turn up thousands of articles on a particular subject, and a lot of them experiment on animals, which isn't necessarily going to tell you what you want. We want to run things through the human test tube, so you can kind of winnow those down. But even so, you might be left with hundreds or thousands of studies, and they're not all the same quality. So this isn't an easy thing to do, but if you persist at it and read about how to do it, you'll get better. I know not everybody has time to do it, but I do invite you to do it. I'm not here trying to, tell you the one right way. I'm here trying to stimulate your own curiosity and your own desire to go out there and find the truth for yourself. But the research does indicate that a whole food, plant-based diet is where you're going to find your food friends and be the healthiest. So I'm hoping you'll move toward that choice.
Mahalo. Have a safe return home tonight. Good night, everyone.